Let's go through LeetCode 689. Maximum sum of three non-overlapping subarrays. The question gives us an integer array, nums, and an key as the input. It asks us to find the maximum sum of three non-overlapping subarray, and those subarray they should not have overlap. For example, if this subarray, the first one is this, second one should be some from the item behind the first one, right? So there will not have the overlap. And also the k will be the subarray's length. So for this example, the k will be 2, right? So it will be 2. So it asks us to find the index. It will return 0, 3, 5, because from this is 0, right? So the first subarray is 1, 2. 1, 2, 3. 3 is 2, 6, right? This one. 4, 5, 5 is 7, 5, right? And also, for this question, it have another answer like a 1, 3, 5, right? That is 2, 1, this one. But it said that the 1, this number is lexicographically larger. So if we have multiple answers, we'll select the one which will be smaller. So for this question, here we have the nums array. What we are thinking about is that for this k, right, we can create a sliding window with size k. The size k, for example, this is 2, right? And to prepare a sliding window sum first. For example, we have a sliding window array. So it's the first one will be the first sliding window, which have the index from 0, and will be for example 1 plus 2 will be 3, right? And then when have this one move to the right, it will remove the on the left and add to the right. So we we prepare a sliding window array first. And this is the first thing what we need to do. And another thing we need to prepare is that we iterate. I use another color. When this slide window, we move from the left to the right, we are going to have another array called left max. Okay, and this array will store, for example, the previous slide window, the maximum sums start index. For example, this is sliding window 1 equals to 3, and the sliding window 2 is also equals to 3, right? So all of the left max currently are 0. And when we move to sliding window 3, it already become to 8. So I say because 8 is greater than 3. So when we move here, we'll have the left max 3 will be 3, right? Means this array will store on its left the maximum sum of the sliding window, the starting index. And when this is 8 and 6, 7, right? We'll see sliding window 4 will be 13, right? So left max 4 will be its index 4, right? And then we move sliding window 5 will be 15. And we have the left max still be the 4 because this is not 15, this is 12, right? Because 12 is smaller than 13. The maximum is still 13. So the second array we are going to prepare is the left max array, which will store the maximum index of the sliding window, which we already seen so far. And the third is that we are going to create a right max. What we are going to do now is we have a sliding window from the end to move to the left, right? So, so the red max, for example, the red max, we have its last one, right? Last one will be the n-1 and minus k, right? Will be the m minus k, and for this one will be the sum of 1, 5, right? And when we move to the left, if this is greater, then the right sliding window will update its index. Here is some kind of tricky things we need to know. That is that because we want to store the lexicographically larger one, a smaller one, right? So when we have the sliding window from the right to the left, if the sum is equal, we should also update the starting index. But from the left to right, only when the maximum sum, only the sum is greater. So this one condition is greater than the previous sliding window sum, greater. But this one will be smaller, equal to. We'll update this one. And after we prepare these 3 arrays, we are going to iterate the sliding window on the left, on the middle, right? So we are going to have 3 subarray, right? And we just iterate this one from the from k to n minus 2k, right? Because this one start will be n minus 2k. So this starting index will be k to n minus 2k. We iterate this one. And for when this window moves in this range, right? While it is k to n minus k, because that should have at least a k size subarray on the left, and also at least a k size subarray on the right. So when this kind of subarray, like a slide window, move in this range, the maximal, we have this kind of array. The maximal of this subarray can change, right? So we have global max to see whether when we to find the maximal sum of the 3, and we record the index. And also this one is storing the index. right? From this one, we store the index, and because we already prepared the sliding window subarray, and we can easily calculate the left subarrays sum and also right subarrays sum, and also use this array to get its corresponding index. And this is what we iterate. So let's begin to write code. So let's say int a equals nums length. Firstly, is that we'll say if a smaller than 3 multiplied k, right? So we'll return, and we have the corner case here, new int 3. And as we talk about, we are first step 1. Prepare sliding window sum, right? So we are going to have int window sum equals new int let's say that is a minus k plus 1, right? Why? Because if a equals k, right, we'll have one element in it. So that if n equals k, we could just have a corner case to calculate. So it will be n minus k plus 1, the size. That means we have an array, this nums array, and the index from 0 to n minus k, right? And this will be end the slide from here to here, right? So this is the first thing we want to compose. So let's write code to compose this, prepare the sliding window sum. We'll have a sum variable for int so we'll say if I equals k minus 1, we'll have the window sum 0, right? First element will be sum. And if I greater equal to k, then on the left, we are going to add the right element. On the left, we are going to have sum minus equals to nums I minus k, right? And the window sum I minus k, I minus k, my minus k plus 1, right? Because that will be the next one for the on the right of the our remove one, right? This will be the first one we include, will be the sum. So we prepare a sliding window sum array first. The second step is that we need to prepare the left max array. prepare the left array, which will store the max to the current index. We store the index of the max to the current index. So we're going to use the we call left new int. So we have int max. Let's say the numbers is always greater than 1. So we just have a max equals 0 will be fine. And we'll say for int I equals 0 smaller than a minus 2 multiplied k. Why? Because we just need this part of the calculator, this part, because we need to allocate 2 k's on the right? So we just need to iterate from 0 to n minus 2k, because we want to see this part, the maximum. So at least there are 2 k's on the right? N minus 2k I plus plus. So let's say if window sum I, let's say greater than max, then we are going to have the max equals window sum I, and we're going to have a left I. Fi equals I. Else so we just left I equals the left in this case we need to left I minus 1. In this case we need to from I equals 1, right? So what about we do this? Left index equals 0. We have the left I equals left index, right? So this is because we are going to return the index, so we need to store the index. And also, once we have this index, we can easily calculate the first subarray from this window sum array, right? So the step 3, we are prepare the right array, which will store index of the max to the current index. Right array was store the index to current index. How to set to the index of max from, this is from 0 to current index. This will be from current index to a minus k, right? For this one, we are going to have an trying to iterate from the end and to the to I, right? Trying to see what is the maximum. And the tricky thing is that if this sliding window sum, because we want to see have the lexicographical smaller one. So if we'll say this one have window sum greater than max. So on the right, we'll have if the window sum greater equal to, so that we'll always have a smaller index. So let's write code. We are prepared, we call write plus the new int n. Have max plus 0 again. Int write index equals we start from n minus k, right? Because the first one is that this is k, and this is n minus 1, right? So the first one will be n minus k, is this element. So we prepare this array for int I equals a minus k, I greater equal to multiple k, right? Because we need to have at least 2 window on the left. If window sum I greater equal to max. Here we need to make sure greater to equal, right? This is greater equal to max. If this is greater equal to max, we're going to update. The same thing is that we update the max equals window sum I and the right max equals sum and the right index equals I. We are going to have right I equals right index. So we prepare these 3 arrays, and because we are going to return the index, from every this one just store the side index of the left sliding window to I, right? So for example, if we have the sliding window move to I equals 3, right? The maximum can be the 0, 1, 2, 3, right? The maximum one. So this will store the max sliding windows index. And also this will be on the right. Also, we get this one. We can also easily to calculate the sliding maximum sum from the first one, right? Because we get the index from here. So the fourth step is that we need to iterate the middle subarray. We know the middle subarray, it is from K to A minus 2 multiplied by K plus 1. Right. So this will be from here to here. Why? Because the last one is N multiplied by K plus 1, right? So sorry, the last one is N minus K, right? Minus K. And so this K will iterate K to A minus 2K, right? So this will be included. So we are said when I equals K, I smaller than this, right? Because we are going to include N minus 2K. We have the three-part sum. We have some variable, and I have three-part sum. If the sum is greater, this sum we just update, and also we get this value, and this value, right? Update these three values. So let's write code for this part. Step 4. Iterate the middle, the second window to get the result. We know the result will be have size 3, both new int and 3, right? And we have a total max, or we call max sum total equals 0, right? Because every number in it is start from 1, which is it will not be 0. So we iterate the second window, it is from for int I equals K, I smaller than N multiplied by 2, minus 2 multiplied by K, and plus 1, right? Smaller than I plus plus. I say in the left sum will be the left max, because the middle part is just a sliding window. For the left part, it will be when it move, right? It will choose the maximal sliding window one, right? Just a just on the left range. Lex max, call left max. Left max, yeah. Left max will be Windows sum. I minus I minus k, right? Because this is the second one is I. First one will be at least it will have a one k space here, right? So this is left max. And we have current or second middle window sum. Middle sum equals window sum I, right? And right max will be window sum right will be I plus k. So I say if the total is greater than let's have a sum. And current equals left max plus middle sum plus right max. Current greater than total. We'll have a greater here, not greater equal to, because we want to have the lexicographical smaller one. Then we're going to update. Result 0 will be I minus k. Not I minus k, will be left I minus k, because this one will record the maximum in the left range. Left I minus k. And result 1 will be I, and the result 2 will be right I plus k. And in the end, we just return the result. Zero, 3, 5. It seems there is some kind of index. Index mismatch here. Four and 5, 4, 6. Let's take a look at why. There is some kind of mismatch. Result 3 total. Total if k equals if some I if greater than total, and this one will be update. We need to have total will be current. Also, let's sum it. For this question, we prepare 3 arrays, and we have the sliding window iterate from the k to m minus 2k, right? Include the range, and so the time complexity will be linear, will be on. The space we have prepared 3 arrays, like window sum, the left max index, right max index. So will also be on.